From the American Society for Microbiology, this is TWiM, This Week in Microbiology, episode number 200.
Hey!
Recorded on June 24th, 2019. I'm Vincent Racaniello, and you are listening to the podcast that explores unseen life on Earth. We are recording today in San Diego, California, where it's always 70 degrees and sunny, so we don't have to go through the weather. We're recording on the campus of San Diego State University, and joining me here, my TWiM co-host, Michael Schmidt.
Hello, everyone, and we have an audience.
And we have an audience, and we have Michele Swanson.
Hi, delighted to be here.
And it is a special episode. Number 200 is a nice number. And we were in San Francisco for ASM Microbe, but Elio couldn't join us. So we decided to come to Elio.
Elio who?
Elio Schaechter.
Oh, that Elio.
Welcome.
Well, you're welcome. You're here. This is sort of home turf for me. I have an appointment here at San Diego State, of which I'm very proud, and I'm glad to see you in situ.
In situ, in vivo. That's and right. I understand you're the guy who ground up cows to make media. Is that right?
I did.
That's all you're going to say about that?
That's all I'm going to say about it.
We won't then ask you about the horses for gonococcus.
Okay, you can ask me about that too. So you want to hear about how I got here?
Yeah, we're going to celebrate you today. That's the plan. Number 200, we're here on your home territory. We're going to talk about you. Could take a few hours, right?
It take a few hours. I'll be brief, as I always am. So I have been a microbiologist for 75 years. I kid you not. So that means that I started early and I didn't quit. That's one way to have all this time being as a microbiologist. So
start at the beginning.
Okay, I was born in Italy, and we had to leave being Jewish during the war, and we went to Ecuador, which was a welcoming country that accepted us and afforded me a rather good education, surprisingly so.
What year did you go to Ecuador?
1940. The war was on. We were on the last ship out of Genoa, Italy, to Barcelona, Spain. On the way home, the ship got torpedoed with the loss of our lives. So we made it on the last ship. Anyhow, but I don't have many horror stories to tell because, in fact, I never lacked for shelter or food. And so on. I was okay. And coming to Ecuador was certainly going to a very different country, a country that was reasonably underdeveloped. It's now developing at a rapid pace, and it's one hell of a country. I mean, I just want to say something about it because it is one of my favorite places on earth.
Why did you go there when you were your family?
We went there because my father found a consul who would give him a visa.
I see.
And he came home and said, "I finally got a visa. It's a visa for Ecuador." And then next thing he said is, "I have no idea where it is." I was a bright 12-year-old. I said, "It's on the west coast of South America." I said, "Good, that's where we're going." That's how it was. Anyhow, we got there, and eventually, so at the age of 14 or so, I was 12 years old when we got there. At the age of 14, I read a great book, Microbe Hunters by Paul de Cruyff, that all of this table know, but maybe the people in the audience may not know. It's a great book that was written for teenagers, essentially, and was made to make you want to become a microbe hunter. So I was going to be a microbe hunter from the age of 14 on. And at the age of 16, something miraculous happened. There was a pharmaceutical company run by Italians. It's a long story I won't go into, but they were the only pharmaceutical country in many countries around. And they had an interesting name called LIFE, which stands for Laboratorios Industriales Farmacéuticos Ecuatorianos. LIFE. And it was called LIFE then. Anyhow, my boss took a liking at me, and at the age of 18 actually, I became the research department, in the sense that every time something new was to be done in the organization, I was given the task of doing it with zero instructions. I remember the day when he came with the machine, he put it on my bench and says, he learned to use it. And I said, what is it? I couldn't tell what it was. He said, it's a microtome. I said, what do you do with it? It makes you cut sections. How do you do it? He said, figure it out.
Did you know what a section was?
I had no idea. I had to learn from scratch. And this happened all the time. I mean, they needed a new strain of typhoid bacilli. They said, go isolate a new strain of typhoid bacilli. So how do I, well, anyhow.
Many of our listeners will relate to the fact that my first job was to make media, but you got a cow.
I was given a chunk of a cow and say, make media. And if you remember media, rich media broths are made from beef.
Brain heart infusion.
Brain heart infusion one. And I didn't need that one, but I made others. And one day, my boss had read in it, the literature they had were old Italian microbiology texts stemming from the First World War. And in it, he had read that there is a medium for growing gonococci. And they wanted to grow gonococci. I don't know why, but they want to grow them. And they found out that a good medium for the growth of gonococci is an infusion of horse penis. So one day, I'm sitting at my table, at my bench, and he comes and plucks down an object about this long and about this big. And I said, here, make medium with this. What is this? It's a horse penis. One of our horses died. They had horses they made syrup with. Anyhow, so I got one hell of an education. I did some biochemistry, some histology, pathology, etc. Microbiology. I grew all kinds of things.
So at any point, did you not like having to figure things out, or did you always love it?
I thought it was normal.
Yeah.
I thought this was what you do. You do what your boss tells you. So I didn't think there was anything.
You didn't know any better.
I didn't know any better. I didn't know this was anything different. I thought that probably other people don't do that, but it didn't go to my head like it should have.
So at that time in 1940, had the agar crisis happened yet? Because in the States, because we went to war with Japan in 1941, there was an acute shortage of agar.
We came from Japan.
And so consequently, all of the agar that was used in the United States during the Second World War was recycled.
Yeah.
You actually took the Petri plates, you re-isolated the agar, washed it, and reused it.
No, we didn't have that problem because we had the company had. I'll tell you something about the history of it. It started out with Germany wanting to extend their reach through South America, and one idea they had is they'll build a lab, something like an NIH, a CDC lab for Ecuador. And so they actually sent in boxes all the equipment it takes to run a lab. And being Germans, they were very thorough. So there was plenty of agar and petri dishes and pipettes and everything you possibly could want. Then the war started, the Germans didn't come. But these Italian families were there, and they were not. A couple had industrial experience, and my boss was actually a pediatrician, but he knew a fair amount about bacteriology then. So that's how the company got started, and it got going. And it was really a successful company because they exported. There were no exports to be had from the United States. The United States was busy doing other things in the war. And so this company would sell to adjacent countries, Colombia, Venezuela, Peru, and so forth. So it went very well. Anyhow, then I went to medical school for 2 years. Okay. The reason I went to medical school is because there's no college in the rest of the world. I don't know if you know this, but in most of the world, you go from high school to a professional school. Engineering, chemistry, medicine. You go straight in, and it's longer. So medical school in Ecuador was 6 years. Mm-hmm. And so I went to medical school because there was no way to become a microbiologist. Obviously, there was no department of microbiology or anything like that at the university. So I went to medical school for 2 years. And then while I was working practically full-time. So I was a full-time medical student, a full-time worker at this lab.
While teaching yourself English.
While teaching myself English, such as it was. My English it improved rather suddenly because I had two American friends who came from, of all places, the University of Kansas. So they one spent a year in Ecuador with her mother, who was Ecuadorian, and the other one was a friend of hers, and he came. So they came to Ecuador and became good friends of them, and of course they didn't speak Spanish, so I had to speak English with them. And my English was just as halting as it is now, only more so. Yeah, I wrote to my friend John a letter, and in a minute I was complaining that I have pains in my bellies. I knew there was a plural to intestines or guts, but I didn't know what the noun was. Anyhow, I then decided that it was time to get serious about studying because I couldn't study microbiology in Ecuador. So I was hell-bent on becoming a microbiologist. So I decided to come to this country, and I went to the University of Kansas, which had one great sign of great quality. They accepted me. I thought there was a wonderful insight in there. So I show up there, and I am a very odd duck. I mean, I'm really strange. I have 2 years of medical school, such as it was. I had 4 years of experience in a lab, and that's about it.
Well, you had been to high school, too.
I had been to high school, but the high school, I majored in biology early on, so I didn't have much chemistry or physics or anything like that.
And you're 20-something?
I'm 22 at this point, 23, 22, I think.
And you went by yourself to Canada?
I went by myself. My parents stayed in Ecuador. Eventually, they moved to Israel. They both died in Israel. Anyhow, I showed up there, and they didn't know what to do with me. So I knew one thing. I knew I had no money. Okay, I had about $100 in my pocket. And I knew that maybe I should be a graduate student. I wasn't clear about it at all. So I knew that as a graduate student, I could get a stipend. I could be an assistant or something. As an undergraduate, I didn't, and I didn't know how to do this. And I was good. I was by myself with my two friends, but I was good and confused. So they ushered me into the office of the dean of the graduate school. The dean of the graduate school at the University of Kansas in 1950 was not the savviest of deans. Is there a dean in the room?
No, he's in the corner.
Anyhow, he looked at my papers and he was an English professor. He couldn't make heads or tails out of it. I mean, just couldn't tell. But I was saved by a linguistic quirk. In Spanish, a high school is called a colegio.
Ooh.
And a high school graduate is called a bachiller.
All right.
And so he says to me, "Is this like a bachelor from a college?" And I said, "Sure."
Today it is.
Sign me up. So I had my strange hejira through this. Anyhow, I got the master's at the University of Kansas. I got a PhD at the University of Pennsylvania. And then I got drafted, which was very lucky, because at that time, imagine saying you're lucky when you got to get drafted. My PhD experience wasn't the greatest, but it's another story. But the Army was drafting PhDs right and left. This is the Korean War. They were drafting everybody, no matter what. And so, but they sent them to labs. During the Second World War, a guy with a PhD would drive a truck or be in a trench shooting. They learned that it wasn't a good idea. So it was easy for people who were running labs to requisition a GI. Just
with a PhD?
With a PhD. And so I went to Walter Reed Army Research Institute, and I worked under a very well-known, at that time, rickettsiologist by the name of Joe Smadel, and he set me up. He treated me. So
that's how you got involved with rickettsia.
That's right. That's how I got involved with rickettsia. And he set me up, and the guy was tough as nails. He was far tougher than anybody ever known. I remember about a week after I'm there, he's walking into the men's room, and he sees me, holds the door open, and says, "Well, chum, what have you been doing?" And I thought he meant hello. He didn't mean hello. He says, "What have you been doing?" And I had to tell him, as he's holding the door open, I had to tell him what I had been doing. Anyhow, he was a very fine scientist, and he treated me, he was indifferent to what the rank was. I was a private, It didn't matter if I was a colonel, as long as I got the work done. So that's how it happened.
But by this time, you know microbiology, right?
I have a PhD in microbiology. That, of course, is a assured indication that I know microbiology. Ha!
Right. You get food and lodging for you and a horse because you have PhD.
Right.
That's what the degree entitles you to.
That's right.
So there's a 1952 science paper. Would that be your PhD? It's on bacillus.
No, that was a little side issue. I loved using the microscope, and I was pretty good at it. My thesis involved the microscope. I was sort of a cytologist, if you want to call it that. I was involved, and so I looked around and I looked at the bacillus and the microscope, and it was doing funny things. So I took a bunch of pictures, sent it to Science, and they published it.
Try that today.
Well,
if you use a fancy microscope, I guess.
Yeah.
Anyhow, that's
And Racaniello then, there's a paper, Schaechter, Bozeman, and Smodell, 1957. Growth of Racaniello. That's what so this is during the war. He's
Korean War.
And he's putting you to work on this, right? I mean, what was the name of this position? It's a postdoc, right?
No, private.
It's private.
He's in the Army.
Private Schaechter.
I'm in the Army, private.
At least he didn't have to worry about what to wear every day.
I didn't. That's right. The uniform was cute. They wouldn't give me a white lab coat because that was for officers. Uh-huh. So what's the next thing? They gave me a cook's uniform because I was white. And the cook's uniform, no, not the hat. The sleeves were cut off here because you shouldn't get the soup up with your sleeves. So we had this cut off sleeves, and we wore those uniforms. Uh-huh. And there were some interesting people with me. There were some rather, I was in a barracks at Walter Reed with half the people there had a PhD, and some went on to become very well-known scientists.
Any names that we know?
Alan Campbell, who died recently. Peter Gajduszek, Rupert Ruckert. What was his name? Ruckert.
Roland Ruckert.
Yeah.
Really?
Yeah.
Wow.
He was there. And then a bunch of psychologists. They had drafted a whole bunch of experimental psychologists. But it was, we had barrack seminars.
Yeah, I can imagine Alan Campbell giving you a seminar on phage.
Well, I knew how smart he was then. Anyhow, after chow, after eating, what did we do? We did what we had done as graduates. We went back to the lab. Imagine the sergeant finding out that these GIs are going to work on their own time. He went bananas. We had to get a written certificate from our bosses that this was okay, because he was sure we were up to no good.
Making alcohol, probably.
Making alcohol, yeah, something like that. Who knows what we were doing? So anyhow, I had these 2 years in the Army, which was superb.
Wow. And
I was married then. My wife stayed in Philadelphia, which is where we had been. So it worked out.
Okay, 2 years in the Army. So then the war ends and you leave.
No, it's not that the war ends. My period.
Your period ends.
Service ends.
All right. What did you do next?
Next, I went to Denmark for a postdoc, and the reason I went to Denmark had to do with Alan Campbell. Alan Campbell, who, for the audience, is one of the smartest persons who ever trod on this earth, was lying on his bunk in the barracks, open bunks, and reading a paper with his GI cap sort of tucked over almost over his nose, and saying, gee, everything that's ever been done has to be done over. What? What are you talking about? It was a paper from Denmark by Lark and Moller, which showed that you could synchronize bacterial cell division. So that was interesting because it was known that bacteria, when they grow normally in broth, in a flask, don't divide at the same time. They're not synchronized. And so he thought that this would allow to study the basic unit of growth, which is the cell cycle, not the growth curve, but it's what happens between the time one bacterium becomes two bacteria. Well, it turns out he was wrong. It's the first time ever that Alan Campbell had been wrong, because it turned out to be not to be so interesting. I can go into that. That's another story. But anyhow, it sent me to Denmark. And one of the other reasons I went to Denmark is because my wife had taken a class. She was a music major, but she had taken other classes. She took a class called Scandinavian Civilization. And she fell in love with the teacher, and B, she fell in love with Scandinavian socialism.
Oh,
all right. Okay. So when it was time to leave the army, and thinking ahead, at that time, this was 1954.
The height of the McCarthy era.
That's fine. At that time, the thing to do if you wanted to be academic is to go to Europe. Even though there are plenty of good labs in this country, but it had a cachet to go to Europe. So where are we going to go? France was the favorite place, the Pasteur Institute. It was the place where everybody wanted to go. But there are a few other places. And this lab in Copenhagen, it fit the bill because after all, it was Scandinavia. So my wife was happy with it. And Alan Campbell had given me his blessing. Mm-hmm. So I wrote to Ole Mole, was his name, my boss. O-L-E, that's Ole, was okay. But Mole, that's how it's pronounced, but there are kinds of umlauts and things. Anyhow, slashes across the O's. Anyhow, I went there, spent 2 very, very, very happy years there. I think Denmark is in fact, it's said to be the happiest country in the world, and I can see why people would think so.
So there's
that was E. coli work?
Yes, well, salmonella.
Mm-hmm. So here, 1959, Nature paper, synthesis of DNA during division cycle of bacteria.
Yeah, but that was interesting because the paper that Campbell had read showed that if you want to synchronize bacteria, what you do is you subject them to temperature fluctuations, 30 degrees for X minutes, 40 degrees for X minutes, 30 degrees, and so forth. And if you do that, they sort of line up. Actually, nobody knows why to this day. So, and what they measured is the amount of how is DNA made during that. And they decided it's like in animal cells, which have a S period, a period where in the cell cycle, DNA is made only during that period. And they showed, and sure enough, that DNA was made during that period. But my boss was a good scientist, and he says, wait a minute, we introduced an artifact in doing this. We introduced a temperature shock. So how about not doing it with a temperature shock? He says, how are we going to do that? And he had a perfectly simple, beautiful idea. If you have a randomly growing population of bacteria which are not growing synchronously, and you give them a pulse or a precursor of DNA, in this case was treated thymidine, okay? You give it to them for what? 5 minutes, 3 minutes, whatever. And then you find out whether all the cells are labeled or only some of the cells are labeled. Because if there is a period, the culture being asynchronous, some of the cells will be in the S period, some of the cells will not be in the S period. Whereas if it were continue, all the cells would be labeled. And guess what? All the cells were labeled. We did this by radiotography, okay? And thus disproving the great paper that had got me to Copenhagen. But that's good science. And then we did something else. We worked a long time about the fact that if you grow bacteria, the same strain, same genetic makeup, in different media, you come up with a very interesting relation. Namely, that the size of the cell is proportional to the rate of growth. The faster they grow, the bigger they are. Okay, and that was interesting. And also the amount of RNA, the amount of DNA, the amount of protein go up linearly with the growth rate. And we thought that was interesting. But it didn't quite, let me spend a minute on it because there's such a thing as doing research when it's a little bit ahead of its time. In those days, this is in late 1950s, everything was molecular.
Oh yeah.
Everything was molecular.
Watson and Crick
had happened, and so everything had to, and the operon model had happened, everything was molecules. And so this, although it dealt with molecules at a higher level of organization, it didn't fit. And that it didn't fit, I can tell you, because my boss, Ole, sent me to England. He knew I was going to England on a visit. He says, go to Cambridge and talk to my good friend, Crick. So go to see Francis Crick, tell him what we've been doing. And Francis Crick, who was, again, one of the smartest people on earth, it took him a millisecond to understand not only what we had done, but the implications. And he said the following. He said, congratulations, you started a new field, but it's over. Going from inception to oblivion in one step. And at that time, that was correct. That was right. It was over because when I came back to this country, I had a faculty position. I had my own lab. I could do anything I wanted. I had a grant. I couldn't follow up on what we did in Copenhagen. But the curious thing, and this is really funny, and I think the people here in the room may want to hear this. There's such a thing as anticipatory research which is done at the time when it doesn't fit with the ethos and with the framework of what you're doing. Well, 50 years later, it turns out that when people studied systems biology, invented systems biology, this is a basic law of systems biology.
Yep.
And all of a sudden, people come to me and says, "My God, he's still alive." And so I got my kicks out of it. So if you wanna, there's another law. There's a corollary. There's the Magasanic Theorem. Boris Magasanic was a famous scientist that maybe the people in the
at MIT.
He was at MIT, first at Harvard, then at MIT, and he said the following. He said, "The more important the finding, the shorter the fame." What he meant by that is, if you make a discovery which fits smack in the middle of what's going on, of what's exciting, it becomes part of the lore, part of the folklore. Pretty soon people forget who did it. You don't quote Lavoisier for saying that water is made up of hydrogen and oxygen, right? It's a given. So the more important the finding, the shorter the fame. So if you want to stay famous, do something which is unimportant at the time.
And obscure.
And hope for the best. Most of the time it'll be forgotten, but if you're lucky, maybe somebody pays attention.
Did you learn Danish while you were there?
Naturligvis. Jeg kan tale dansk.
Sure, yeah.
Naturally, I speak Danish. Danish is a terrible language. It's much as I love
We're going to
Denmark,
get notes.
Much as I love Denmark, language is not their forte. It's a rather difficult language. To determine if you can speak Danish, you ask someone to say the following, which I'll tell you, which means red gruel with cream. That's how. Obviously, I don't say it right, but I try to pass. So the Danish is not a language that's used by many people outside of Denmark. It's related, or it's a Scandinavian language. It's related to Swedish and to Norwegian. It's very close to Norwegian in writing. In pronunciation, it's very different, and it's a bit more distant from Swedish. But we had an interesting experience with learning Danish. My wife was, she loved Denmark and she was going to learn Danish, and I did a little bit too. But what we found was, in every other country, if you go to any country and you pick up a few words of the language, people say, isn't that wonderful? If you say bonjour, say, you parli français. Buongiorno, parli italiano. In Denmark, we had the opposite reaction. People did not want us to do it. My boss, when he found out that I was learning this, said, "Why are you wasting your time?" And this was very strange because the Danes were very friendly towards foreigners. It was really xenophilia, not xenophobia. The Americans were beloved in Denmark because of the Second World War. Anyhow, I finally found out what was behind it. It was really curious. What somebody finally told me was, look, we are a small country. We have 5 million of us. Every bit of culture we have is imported. It's imported from other countries. We have very little of our own. The only thing we have is our language. Leave that to us. Don't butt in. Stay away from it.
Interesting.
So how many languages is that?
What?
That you learned and spoke over your years? Italian, Yiddish.
I speak 4 languages, but English is my best. I speak Italian because I was born there. Right. Spanish because I lived in Ecuador. I had to learn German because my friends in Ecuador at the beginning were all refugees would come from Central Europe, and they hadn't learned Spanish yet, so they spoke German. And I knew some Yiddish, which is, is the language of Eastern European Jews, and it's derived from German. And so knowing Yiddish helps with German. So I learned German in Ecuador. I learned Spanish and German in Ecuador. I learned English more or less in Ecuador, and then a little bit of Danish.
What about Yiddish? You got Yiddish?
My Yiddish is okay. I can speak it. I can tell jokes in Yiddish, but that's about it.
So 2 years you spent in Denmark. And then where did you go next?
Then I got a job at the University of Florida, in Gainesville, Florida, which had a new medical school, brand new. And that was exciting. To be honest, Gainesville, Florida is perhaps it's not Paris. Okay. So it's not the most exciting place in the world, but it was fine. And what was exciting was that we started to start a new medical school. And I'll tell you, very funny, this is a time when grants from the NIH were there for the asking. Some of you remember that.
What years are we talking about?
1956.
Okay.
58. That's when I went to Gainesville. So I got a grant. There's no question about getting a grant. And so medical schools decided to hire PhDs because the PhDs could pay their way. Didn't cost them anything. They got a grant, they paid their way. So what happened was they hired a whole bunch of PhDs in anatomy, biochemistry, and microbiology departments. And these were people who didn't have a clue about medical education. Nothing. So what did we do? We said, we said, science is a good thing for medical students, so let's teach them science. And it didn't matter what science, because the more the better.
That's right.
It was the most nonsensical time in medical education ever. So nonsensical that in our department we decided, it was a second year course, we said it'd be nice if the students learned about the biosynthesis of purines and pyrimidines. It never occurred to us that they had a biochemistry course the year before where they had been taught about the biosynthesis of purines and pyrimidines. It was absurd beyond words. So that lasted a while. Then the 50s happened. And the 50s were a time of sort of increased awareness of people. Awareness about their own bodies, their own mind, their own rights. And medical students were included in that. And maybe Michael, you remember, it's probably before your time. But
it is before my time. Yeah. I heard stories.
But these medical students would actually rebel and say, what the hell? Why are you teaching us that?
They still do that, by the way. Medical students.
And well, they should. And well, they should. I think they're totally entitled to ask that question because we did not know. Okay, and by now, people like yourself, of course, are highly sophisticated in what medical students should learn, but at that time we didn't. And so we had a great time doing this.
But you were doing research also, right?
I was doing research, and I had a nice lab.
Tell us roughly, what were you doing? What were your interests?
Well, I was still interested in bacterial growth, and I did two things of note. One is to look at the statistics of division between bacteria. Since I was interested in exponential growth, with cells growing, the question was, do they all do the same? So we looked under the microscope, and we timed not only bacterial division, but also nucleoid division. And with the help of an extraordinary man by the name of Arthur Koch, you know who that is.
Arthur Koch was the man who taught me about cell division at Indiana.
Wow.
So I learned more cell division and more...
And you wanted to know.
Which is why I often go on digressions into peptidoglycan. Otherwise, he'll come and haunt my dreams that evening.
Yeah, he's no longer with us, but he was a bright guy. And he did the math. He wrote models for what we...
Before there were computers.
Oh, yes, before there were computers. So he wrote models and we published them. The other thing which I did was more or less incidental. It bothered me that when people were looking at what's inside the bacteria, they would smash them up, typically using a thing called a French cell.
A French press.
French cell, which is a way of decompressing putting bacteria under high pressure and then decompressing, and they burst. And it bothered me because I thought this was a good way to destroy what's inside. So instead, I took spheroplasts, these bacteria without a cell wall, which are sensitive to detergent, and just whiff a bottle of detergent over the culture, and they lyse. And they lyse without any pressure. And when you look at that, you find that the ribosomes of bacteria are strung together along the messenger RNA in structure, which we now call polysomes or polyribosomes. So this is an example of the Magasanic law about fame. So I discovered that bacteria had polysomes. My fame lasted 3 weeks because everybody knew that bacteria had polysomes. So it's an example of that. But that's, anyhow, I did that and a bunch of stuff like that.
Jacob and Monod get credit for the concept of messenger RNA and the operon. But the real wonder is the polysome, because understanding the coupling of transcription to translation and how messages stay around. Because as you all in the audience know, mRNA doesn't live very long in bacteria, unlike the eukaryotes. That's why we have this wonderful product called RNA Later to enable you to get RNA out of bacterial cells.
So the years you were at Gainesville, 16 years you said?
No, I was in Gainesville 4 years.
Oh, 4 years.
4 years. And then I went to Boston because a friend of mine, Ted Park by name, was at that time a very well-known microbiologist who discovered peptidoglycan. He discovered that penicillin works by inhibiting the synthesis of peptidoglycan. Anyhow, he'd been offered a job of chair at Tufts, and he wrote me a handwritten note, a very casual guy, and says, if you are interested in going, I may be interested. It took me a microsecond to decide that I wanted to be in Boston. And so I went to Boston, to Tufts University, and I've been there, I was there for 35 years. And there, by the way, I got to brag about my department.
Sure.
A guy who got his PhD in our department and an MD at Tufts just became the editor-in-chief of the New England Journal of Medicine. Not bad.
Not bad.
That's pretty good.
Yeah, sure.
Eric Rubin, maybe you know the name.
Yeah.
Anyhow, you know.
That's where I had the pleasure of meeting Elio. I did my postdoc in that department, and it's wonderful scientists, but also a commitment really to training graduate students and postdocs.
So I was chairman there for 23 years.
When you first went, though, you weren't?
No.
Not as chair?
No, I went as regular assistant professor, associate professor. Oh, and I got a letter 2 years later saying, now you have tenure. I said, I didn't know I didn't have it. Those were the days. In those days, you just didn't ask.
Yeah.
Anyhow, so I was chairman of this department, but it was easy enough to be chairman. First of all, I said, if I can be chairman, anybody can be chairman. But secondly, the real reason was that my previous boss, had laid down the law that the department was going to be a total democracy, that he was not going to have more vote than anybody else. And I continued that. And doing it that way meant that everybody had the responsibility. You don't like something, you fix it.
That's right.
Okay? I wasn't in charge of everything, fixing all the problems. So that was very nice. So when my successor came to interview, there was Kathy Squires, Columbia, you must have known her.
Right.
So I told Kathy, we have a rotating chairmanship system here. The term is 23 years. Anyhow, that's my story.
So what did you work on in these years at Tufts?
Most of the time I worked on a question that's still open in a way. How does the chromosome of bacteria, the nucleus of bacteria, divide? Clearly, it does not have mitosis. There's no such thing as a mitotic spindle and centriole. So how does it divide? So Jacob and Monod and Lvov and others had postulated that maybe the DNA sticks to the membrane on both sides of the midline. So this is the midline of the bacteria. One strand sticks here, another strand sticks there, and as the bacterium divides, the two strands come apart. Well, that's a lovely idea that is a great appeal, but it was not easy to prove. So how do you prove it? So I spent a lot of time probably doing the wrong thing, because I did it biochemically, by opening up the bacteria. I was good at opening bacteria gently, so I knew that I wasn't destroying everything. So we found the technique that allowed us to isolate DNA membrane complexes. Mm-hmm. And we did a lot of work with that, and we showed that how many attachment sites there are, and we did a lot of work on that. So I spent basically a lot of time on that, plus a few other.
There's some phage papers in there, I noticed.
There's some phage papers, yeah. We looked at what happens to phage DNA. And,
right.
Not so clear, but yeah.
And there's one with Corona. What was that about?
I spent a sabbatical with Corona.
Okay. And where was he?
At MIT.
MIT, okay.
So I wanted to have a sabbatical, and I wanted to have a sabbatical in situ, that is in Boston. So I did something where I thought it was rather interesting. I thought it would work for me if I did not step foot at Tufts for a year. And I didn't. For a whole year, I had lab meetings with my people at my house. Or if they wanted to come to MIT, we had at MIT. I did not step foot, so it was like being away. And I didn't answer the phone. They said, don't call me that year. Don't call me. Somebody else is in charge. Andrew Wright was in charge.
Yeah.
So.
And then, what year did you close your lab?
1995. I had a grant until the day I left.
And was that your decision to stop?
Yeah, yes and no. It was my decision, but I tell you, I was noticing that I was getting older and frazzled a little bit, and that my work did not have the oomph that it had before. I still had postdocs and so forth. I didn't have any students because I didn't want to have students towards the end. But I had some postdocs who did the work for me, and I was almost not with it. And so I said, it's time to leave. And so I did, and I came to San Diego because cherchez la femme. My wife had died, and a childhood sweetheart from Ecuador was living in San Diego, and she found me in Boston, and the rest is history. So I came here.
And speaking of history, I did read your memoirs, and I love the story that you had met Edith and gave her a nickel or a penny and said, when you grow up, call me. And then 50 years later, she did.
Yeah, that's right. She made fun of me. I was boxing when I was maybe 14 years old, and she was making fun of me. So I came over and says, here, when you grow up, call me. And she used that coin.
Did she give you the same coin back?
I don't know.
You don't know.
Do you miss lab work at all?
No.
Okay.
No.
Don't tell these guys.
I don't tell these guys. No, look, lab work there is nothing more satisfying than a good result.
Yeah.
And a good result that your trainees have is
That's right.
maybe even
better.
more exciting.
That's even better. So there's nothing like it. But after a while, you expect that, and you're just not as sharp. Some people are. This is totally variable. In my case, I was noticing I was slowing down. But I wanted badly to stay in science because
Can I interject? You were had a research program. You were chair of the department. You also authored a textbook for the medical students that we still use at Michigan today, the Schaechter textbook, and also an undergraduate textbook. So you had a lot going, and you were chair of ASM or president of ASM during that period as well.
Yeah.
So I would be tired too if I had all of that going.
Yeah.
You were operating at a high level in many arenas.
I thank you for saying that. I didn't know I was doing that. If I had known, I would have done something about it.
Obviously, you love microbiology, though.
You can say that. Yeah, I love microbiology, and I love microbiologists. They're wonderful people.
But when you came here, you didn't do nothing, right?
What?
When you came here, you didn't.
Oh no, I started. No,
there
was a person on campus here, Judith Ziskin by name, who had done some very fine work on the origin of replication. She had been the first person to, together with other people, to isolate OREC, the sequence that's responsible for the origin of replication of the E. coli chromosome. And she had an active lab, and so I came, and I was living across the freeway from here, not very far. I could see the building. And I came, and a couple of times a week I would hang out in her lab, and she was wonderful. And I was like a postdoc. I mean, she wasn't sure what to make of me, and I wasn't sure what to make of her. But I did a few experiments, and I did an experiment with Malloy and his student, and so I was playing around, but it was sort of by proxy, having a, I wasn't sure I knew how to use a pipette, so anyhow, but.
Then you started the blog?
Then I started
that around
the blog.
That time?
So some years later, I realized that I wanted to write, that writing is something I had always done, and I enjoyed it. And I realized that there were no good outlets. I wanted to be a columnist, like a newspaper columnist. Yeah. Mm-hmm. But there are no new columns where you can write in microbiology. No, you can write for what there's then the ASM publication. Now,
used to be ASM News.
ASM News. Yep. So you could write once a year, you could write a piece, but it wasn't a place where you could write something once a month. So I called, I was good friends with Ray's buddy, Chris Kandayan, who was at ASM in communication, and who was a brilliant guy. And I said to him, what should I do? And he says, do you know what the blog is? And I said, I have no idea. What's a blog? So he explained to me, this is now,
2005-ish.
2005, 2008 maybe. Anyhow, he says, we've been talking at ASM about having a blog. How would you like to do it? And I says, well, good. So he set me up with the software, gave me advice, held my hand, and we've done Small Things Considered, which is his title, by the way. I think it's a great title, nice, and I can brag about it because I didn't do it. So Small Things Considered has been going on for 11, 12 years.
Wow.
And we have, from the beginning, we post something twice a week. We have not failed once.
Wow.
Not once.
And you've not done reruns either.
We have once we did a rerun, yes.
But it was needed to be done.
It was needed, yeah, it was something needed to be done. So we have 1,100 posts, which is a book this big. If you were to print it out, it'd be a book this big.
Wow.
So it's a lot of fun, and I work with other people. First with a lady in Hawaii by the name of Mary Ewell, who the people at San Diego State know about because she was a pal of Forrest Rohr, worked with him, you know, very well.
Well, she's a self-trained scientist.
She's a self-trained scientist, a fantastic person. I tell you how fantastic she was. I get an email from this person saying, I saw your blog and I liked it and I thought of doing something like it, but I like yours better, so why can I help you? Do you need someone to proofread? Proofread? I don't need anybody to proofread, but who are you anyhow? So it turns out she lives on the big island of Hawaii. At that time she lived in a small house on a lava field, all by herself. And she had a PhD in biochemistry from Hopkins, but I never used it. She had been a bit of a hippie. She had had a alternative bookstore, alternative food store, alternative everything. And then eventually got into some tech writing. Anyhow, she and I got along very well because the second email I ever get from her, in its entirety, it said, have you ever had a colonoscopy? This is a person I can deal with. So we got together and she helped me. And I like to work with people. I never worked well by myself. So working with her set me up and it went very well. And then eventually she stopped. She wrote a couple of books, two with Forrest and one by herself called The Secret Life of Phages, which everybody in the room should know about. It's a fantastic book. Absolutely fantastic. Anyhow, she's still around, and I acquired new helpers. Yep. And so my major one is Roberto Colter, who was a professor at Harvard, and who is one hell of a guy, just incredible. And then there's a guy named Christoph Weigel in Germany, and two younger people, and our latest associate blogger, I'm really proud of. Right.
Oh.
Her name is Janet Kim. She is a sophomore at Princeton.
Wow.
Holy moly.
She sent us a piece. It was Out of the Clear Blue Sky. It was beautiful. It was really well written, well thought through. It's rather amazing. So we said, fine, published it. Sent us another one, just as good. So we thought, well, let's try her on something we want from her. Perfect. So Christoph said, why don't we make her an associate blogger? So here's this sophomore at Princeton, an associate blogger, and she's edited pieces. Bloggers edit. We have a lot of pieces from outside, and so she edits beautifully. She's just brilliant.
Wow.
What can I tell you?
That's a great story.
So the other thing you started was a podcast, right?
I didn't start a podcast.
Well, you started
a podcast.
You joined us. Why did you join us?
Because I like to talk.
Okay. Good reason.
No, I'm not the type who thinks of myself as being part of social media. I thought social media are out there, I'm over here. But it worked for me. And when you asked me to join, and Stanley was part of it, whom I knew and trusted, and I thought this was good fun. It's like sitting around over a beer and discussing a paper. I mean, what could be more fun?
Just like in the barracks.
Just like in the barracks.
That's right. That's right. So you wrote this article with Stanley, The Era of Microbiology, a Golden Phoenix. Remember that? And you say there major challenges lay ahead to impart the broad training needed to entice and enable the next generations of microbiologists. Are we doing that?
Yeah, I would say. I mean, I'm involved in a course that joined between UC San Diego and San Diego State. It's a graduate seminar that has a unique characteristic in that we bring in a new lecturer for every lecture. We don't lecture, and we don't worry about how much. But our coverage is several people in the room are alumni of the course. The course is unique, but we don't care about coverage. The reason is you can cover everything anyhow. So what's the difference? Right. You might as well choose. So we choose things on the basis of excitement. The students in that class, alumni and present, are terrific. The amount of excitement that they generate is unique. I'll give an example. A course like that, we're not going to take exams very seriously. In fact, we tell everybody gets an A. It's a pass-fail course, A B is a flunk. I think we've given a B once.
So you give grades, but
we give grades, but that happened to be an
don't
A.
tell anyone. You'll have all the medical students signing up, or medical student wannabes.
Anyhow, the exams, we have a midterm, which is take home, write a grant application about something. The final is a single question. Write an essay on a subject of your choice. Not on your thesis. That's the only limitation.
Yeah.
It's exam time. They're taking other courses. They're busy with other exams. They kill themselves writing. And the writing that we get is fabulous. It's really fun to read. And so I can't imagine a better pedagogic situation, a happier family group than that course.
Okay.
And do they post some of that, or do you post some of that on your blog? Small Things Considered.
We posted some on the blog.
Generated by the students.
In fact, people in this room have written for the blog. So.
That's terrific, to get lots of voices.
Yeah, and writing, actually, opening the blog to students is important, because I think you live in that world, and you should be exposed to it and have a chance to write on it and so forth.
So between the blog and the podcast and teaching, you're keeping up with a lot of microbiology. So is there any particular area that really excites you?
Mushrooms.
Why?
Because mushrooms have been I had a hobby when I was in Boston, which was picking mushrooms and studying them, wild mushrooms. And I wrote a book about it.
In the Company of Mushrooms.
In the Company of Mushrooms. And I don't do that much anymore, but I did for a long time. I was very busy writing and thinking about wild mushrooms.
Okay.
But is there something in microbiology that excites me? Ecology. In fact, you allow me a saying. Theodore Dobzhansky, a famous geneticist, said, nothing in biology makes sense except in the light of evolution. I would like to say nothing in biology makes sense except in the light of evolution and ecology.
Yeah, that's the microbiome.
Who's putting pressure on the organism, huh?
Yeah.
Who else is there?
The organism does not exist in a vacuum, and so to understand its environment and its reaction to its environment is what it's about, and it's very exciting. But you brought this up in a conversation we had elsewhere just yesterday, but the other day, Saturday, whenever. Anyhow, the intent of Small Things Considered is to bring out the excitement in microbiology. That is not necessarily the latest discovery. We don't deal with news. We don't deal with Zika virus. Sorry about that, but that's for the newspapers, and that's for other blog sites. We don't do that. We deal with excitement. And so we deal with exceptional things which are exciting and which we think are worth pursuing. And there's an infinity. I have a backlog. I could write the blog for the next year. It's just full of stuff.
What do you think is your most significant contribution to the field?
Oh boy, I can tell you one I'm very proud of. I figured out how to teach microbiology to medical students. And that resulted in the book that you mentioned. And that was different than the way it was done before. So it
was transformational. It's used. Yeah. It's used across the country. And if you think about the adage that you just offered about evolution in ecology, that term is actually called infectious diseases because it's about the microbes reacting to the host, the immune system, where they are in context in the patient.
There's one more. Thank you. I like the affirmation of this.
Yeah, it's true.
This helps. There's one other thing. When I was an officer at ASM, I was, you as Michele knows, you pick a topic about something you want to concentrate on because you're in office for a year, you don't have much of a chance to do it. So my thing was to emphasize the international aspect of ASM. And I had a hand in that. So I like that.
If you hadn't been a scientist, what would you have done?
I would have been a historian. I like history.
Any particular kind of history? Modern history, ancient history, medical history?
Probably the history of the Renaissance. I thought the Renaissance was the most exciting time in history.
If you could have dinner with anybody, living or not, who would it be?
I think François Jacob. He was a fantastic writer, fantastic scientist, and from what I'm told, a fantastic human being. So I would have enjoyed him.
Elio, RNA or DNA?
DNA.
All right, I have a present for you before we stop here. This is from Mark Martin.
Oh, my God.
Who told me to tell you how much you mean to him and how you mean to his...
What?
You.
Yes.
Okay, he wanted me to tell. He has... his wife, Jennifer Quinn, made these for us. All right? And...
oh, my God.
It's glow-in-the-dark bacteria. They are... We all have one.
And it says TWiM.
It says TWiM. So if you turn the lights out, they will glow.
Or so he's
we
playing.
have too much light.
Yes, here. But tonight when you're...
okay.
Under the covers,
Thank you. His wife made she does these paintings with luminous bacteria, and she made a painting of me.
Yes.
Which is really amazing. Yeah. It's incredible how she can draw expression using luminous bacteria to paint with. It's amazing.
That's a really good one. I've seen that one. Yes, it's very nice. All right, that is TWiM number 200. I can't think of a better TWiM to have for number 200. This was great. TWiM, most people listen on your cell phones or portable devices. We'd like you to subscribe to the podcast so we know how many people are listening. And that way you get every episode as we release them, about 2 a month. If you really like what we do, consider supporting us financially. You can go over to microbe.tv/contribute, and you could use Patreon or PayPal to give us as little as $1 a month. From that, you get terrific science, not just TWiM, but 4 other podcasts. There's no better deal in the known universe, in my opinion. And questions and comments, TWiM@microbe.tv. Our special guest, it's not really a guest because she's on the podcast all the time, but for this one episode, our special guest, Elio Schaechter from Small Things Considered. It's been a pleasure.
So nice. Thank you so much.
I hope you liked it.
I loved it.
I thought you would say no when we asked you.
Oh, yes. No way.
Thank you so much. Michele Swanson's at the University of Michigan. Thank you, Michele.
Yes, and thank you for having us here in San Diego. It's wonderful to see you.
Michael Schmidt's at the Medical University of South Carolina. Thank you, Michael.
Thanks, everyone. Thank the audience as well.
I want to thank all 3 of you for doing this regularly with me because you give your time selflessly, and we have great conversations. So thank you. Thank you so much. I'm Vincent Racaniello. You can find me at virology.ws. I want to thank ASM for their support of TWiM, and Ray Ortega for editing our episodes, our producer, and Ronald Jenkins for the music. Thanks for listening, everyone. We'll see you next time on This Week in Microbiology.